Good evening, everyone. My name is Alfredo. I'm working as a Prime Minister Research Fellow in the Department of Electrical Engineering and IIT Patna, and I'm one of the TAs for this particular course in Embedded System Lab. So, in this particular degree, we'll actually see an implementation based on STM32 Cube ID and STM32 board, that how to use an STM32 Nucleo board as a GPIO output in configuration. So let's first open the STM32 ID that we just have installed. So it might take some time to open that particular software. So when you open the software, let's go to new, then new STM32 project over here. So over here, you can see that there is a console is there, a person's figure is here. So you have to go there and log into your ST account over there just before start doing all the calibration over here in the software itself. You just have to log into the okay. So when you hit that new project, so this kind of interface will come over here in the screen, and over there you can see there is a tab is there that is board select. So you click on the board selector, so through which we'll be actually selecting that what particular board on which you'll be working. So over here you can see I have a nuclear board over here. Now in this particular nuclear board is Nucleo f401RE. So we have to choose out of all the nuclear board that is there in this particular uh, app over here. So we first have to choose the corresponding board number that we currently have and on which we'll be doing the experiments over here. So let's write 401RE. So our nuclear board is Nucleo F401RE. Just write, uh, over here you can see that when you type this particular 401RE, over here you will see this particular board is coming. Now we just select this particular board over here. So now it will show that what what is the how the board looks like, what are the informations that you need to know about this particular board, what features it has. So over here you can see that STM32 microcontroller is an LQFP 64. It supports these packages. There is an oscillator, crystal oscillator with this particular clock rate over here. Then you have board connectors through which you can connect the Arduino Uno V3. Expansion connector is also there, so you can connect your Arduino with this particular board itself. Okay, so now you can read all these details by yourself. For the time being, let's just go to start the project over here. So now you can press this next button. After you press next button, so you can see that this particular pop-up is coming over here. So you need to write your project name. So that's because we'll be using this particular Nucleo board as GPIO output configuration. So therefore, we'll actually try to implement operation that is LED blinking on the onboard LED that we have on Nucleo F401RE. So let me just name it as test link, and rest of the things you can keep it as it is and then finish. So it will take a couple of time to finish this particular project compilation. So it will start create the project and then you'll see there is a pop-up, there is a pop-up screen that will come from which we can configure all the pins of this particular STM32 board. So it is downloading some of the packages. So let's just wait for a minute. created over there. So the creation is been now completed. So you can see that test blink has been created over here. Now, what we'll be basically doing is, so there, if I just zoom it over here, you can see there is a pin EA5 over here. So this is labeled as LED2, LED2. So this is a green LED. This is an onboard green LED, which is provided in the Nucleo f401RE board that I have here. So what we'll do is basically we'll do toggling operation. So we'll uh, blink the LED over here. So for that, you can see that there are several pins are there and you can actually manually configure them. But over here, you can see that some of the pins have already been configured. So over here, for example, this PA13 is configured over here. Even LD2 is configured here as GPIO output itself. So which is our main goal for this particular task. So we'll be using this LD2 as GPIO output as well as we'll be blinking the LED or the blinking onboard LED over here. Even you can change the setting by just uh, left clicking onto the panel that you've been selecting. So for example, over here also, if you just left click it, so you can see that what are the optionalities that you have. For example, if you want this particular pin to be for it's a PA5, it's now GPIO output. You can also configure it as GPIO input. So, but we'll be using a GPIO output. So let us keep it as GPIO output. So now over here, if you come, so you can see that system code. So you can see that these systems have been as because we'll be using GPIO. So let's just head to GPIO over here. So now you can see that PA5, all the characteristics of PA5. If you just click over here, you can see that now, as because we have selected PA5, now this has started showing that this is the indication that we have selected this particular thing. So let's just see the configuration that has been already been created by the app itself. So this console that has already configured this particular pin for us, it has configured it as output level low. So what does this basically mean is when we'll be initializing this particular LED blinking operation, so it will be initialized with LED reset. That means initially it will not glow. Then GPIO mode, so it's output push pull mode. So there are two modes, output push pull and so this open drain configuration. So there are two in case of push pull configuration, there are two MOSes, NMOS and PMOS are there, and you can give a command from the output register that it could be either 1 or 0. If it is 1, then the PMOS will be activated and it will connect the LED to the VDD, and then the LED will glow. And in the other case, if you pass the 0 over there, then NMOS will be selected, and as NMOS will connect the LED with ground, and therefore the LED will not glow. So in this way, the output push pull method works. So you can understand this output push pull method from the datasheet itself, from the this F401RE chip. Now, along with that, so already you can see that pull up, pull down. So there are another two switches are there. By using the switching mechanism, what we do basically, you can manually pull it up or push it down. So therefore, over here we have not chosen those manual operations by which we can pull up or pull down this particular LED. So therefore, we have chosen no pull up and no pull down. And maximum output signal speed, it is basically basically means that how fast you actually want to blink that particular LED, whether it will be at a low clock or it will be at high clock. So let us just keep high for this particular application, and this is a user level, so you can change this particular label as well. So let's just keep it as it is LED1. And over here you can see that there is another pin that has been configured. So this is basically the PC13. So this is a blue push button. So if I just show you on the board, so this is the board. If I just show you, so you can see there is a button. So if I just so you can see there is a blue button. So this blue button is basically push pull. Uh, this is a push button. Okay. So you can just push it over here. You can push this particular. So this button, this operation for this button also we'll see in the next tutorial. But for this particular tutorial, we'll be mainly focusing on the blinking of the LED, that is blinking of LED2 PFI. Okay. After that, on this particular console, you can see that there is a block that is clock configuration. So this clock configuration, this basically gives you a glimpse about that what is the clock configuration of this particular board over there. So you can see that this particular board has input frequency which ranges maximum up to 50 hertz in here, and there are several mux operation mux are there by which you can control the uh, frequency into so over here you can see that this is the input frequency and these are the output set of ports over here, how much frequency you can get. For example, over here you can get 84 megahertz, over there 84 megahertz, and you can see that this whole thing is basically controlled by set of masks. So even you can change the particular frequency level. For example, by 4, you just have divided this particular frequency by 4. So over here you can change that whatever frequency line was there, it was connected with these particular ports. You can see that the frequency value is now changing over here. But let's just keep it so for example, this is another flag. So you can see that if you just put divided by 1, so you can see there is a red flag is over here. That means this particular port cannot support this frequency, operating frequency. So you can see that the flag is showing that 80D1 peripheral clock frequency must be less than or equal to 42 megahertz. So over there you can choose 2. So now you can see that there's no issue with this particular frequency. So 42 megahertz is okay for this one. So we'll not mess up with this configuration. So this configuration is also done by this particular STM32 cube ID itself. So after that, you can just go over here again, and then what you do is there is a here sort of shape is there. So this is basically device configuration tool for code generation. So you can just hit on this particular button. Now you can see that this will be creating the C++ codes for you, that whatever configuration you have done over here, so it will be now instantiated using the C codes. So it might take a couple of minutes. So now from the console from which we were configuring all these pins, from there we now have come to the C code. So whatever configuration we did over there, that now has been basically written in the form of C code. Now our aim is basically to blink these LEDs. So over here, let me just show you. So this is the main function. So this is main dot h. So this is basically the header that we can refer to. And over here, this is basically the outline or the sketch of whatever main things have been written over here. So this is a very huge script over here. And this is basically the outline that we have. For example, it starts with main.h. So there are some GPIO functions are there, UART functions are there. So let us first go to the code. Then we can go to the src file and let's move to main.c. So over here, you can see that this main.c has already been selected. Otherwise, you can, if this main.c is not instantiated by itself, so you can go to main.c by yourself. Okay. So SRC basically contains all the main files over here. So you need to go to SRC for example, after you close this particular application, if you just again need to see all the configuration that you have in terms of C code. So you have to go to test blink, then you have to go to show code, then SRC, and then you need to head to this main.c file. Okay. So as we have discussed, so this is basically the outline that we have over here. Now let us go to the MX GPIO init part. So this is basically from the void. So let's go to the yes. So over here you can see that uh, this thing basically instantiates all the GPIO operations that you have over here, that you can incorporate over here in this particular board itself. So you can see that within this particular static void uh, configuration, you can see that clock has been enabled. So there are several clocks which have been enabled over here. And then what we need in this particular tutorial, that basically this HAL GPIO write pin. By this HAL GPIO write pin, what we can do is we can send some command into that LD2 pin, that whether it has to be at set condition or reset condition. So what we'll be using is basically this particular command over here. So you can see that this GPIO pin is instantiated with GPIO pin receipt. So that is what we have initially selected, that PA5 or the LD2 pin should be instantiated or initialized using uh, reset condition. That means the LED will not blink. So that is why you can see that when LD2 pin has been instantiated over here, it has been instantiated or initialized with GPIO pin reset. That means LED will not glow at the first instant. Okay. So what I'm going to do is I will just copy this thing and let's move to main point. So over here, you can see that the main point basically starts with the initialization of all HAL libraries. And then the system clock is configured. So the system clock that we had seen, that there was a console after the console for the configuration of the pins. So there we had seen that there were several functions that basically controls the operating frequencies at different locations of these particular board. So that is whatever we have configured over there. Now that has been written over here in the system clock config. If you just want to see what is basically inside this particular system.config, so you what I did is basically, let me just show you again. You select this particular thing and then you can press F3 on your keyboard. So if you press F3 on your keyboard, it will head to the main functionality of this particular system clock config. So you can see that there are several scripts written over here, which basically instantiates all the necessary locations at which basically the operating frequencies have been instantiated using the app itself. Okay, so let's again head to main.void over here. So if you go to main.void, now you can see that your MX GPIO unit, so all the functions that are related to the GPIO operation has already been initialized, and the functions I have shown you just over here, you can see that all the definitions of these functions have been written over here. Now you can see that this int main void, it basically comprises all these things. Then what you have is a while loop over here. And then after this main basically ends. So this is the end of the while and this is the end of the main part. Now, what happens is when you run this particular thing on, or when you dump this code into the board itself, then what happens is this particular part or this particular code snippet runs for once, and then what happens is whatever content you write inside this while loop, it will be run again and again. So it will be looped over time. Okay. And whatever configuration or whatever operation that will be doing, we have to write inside this file. And then you have to follow this particular convention that whatever code you'll be writing in this particular while loop, you need to write in between user code begin 3 and user code end 3. And why it is so? Because, for example, if you go to this part again, and let's say you reconfigure some other codes, and then again you have to do the code generation, and it will head you to the main.c file again. So what happens is that if you write anything outside this particular block, outside this particular thing, this particular part. So let's say you are writing something over here. So the moment you configure something else on the previous console and you do the code generation part again, what will happen is that whatever you write outside this particular part, it will be erased. So to avoid that, it is basically recommended that whatever you write inside this file, you maintain your write up in between user code begin 3 and user code end 3. So over here, let us start writing the functionalities that we want for this particular example. So what I need is basically this HAL GPIO write pin first. So let me just copy this thing. So sorry. So I can go to main void over here and let me just put this thing in here. And what I will do, I will consider a delay term. So to consider a delay term, what I write is L delay, and let's say 1000 millisecond delay I will consider, and need to put a semicolon over here. So then you can see that this yellow indication was there, that was something was incomplete over there. So the moment you, for example, let me erase this thing, so you can see that there is some pop-up is coming. So it is saying that missing semicolon. So I need to put the semicolon here. And again, let me just copy this thing and paste it over here. So what I will do is I will first keep the configuration as set. So what does it mean is basically when it will be configured all this max image CPI. Initially, the LD2 pin will be initialized with reset. Now then what will happen is after you pass this thing, now this while loop will be instantiated. Now when the while loop will be first started, it will come at this particular line. It will read that LD2 pin GPIO code, and then we are specifying the port name. And now you can see that magic will happen is that GPIO pin set. That means that from that point, the uh, LED will start here. Then you have put a delay. That means for that particular time, the LED will glow, and then you can see that HAL GPIO right pin. Now you are resetting that particular thing. That means now LED will be uh, stopped. And then again, you put a delay of 1000 milliseconds. Okay. So now we are done with the coding part. Now what we'll do is basically uh, we'll compile. So now what we'll do is basically we'll compile this particular code snippet that we have written down. So you can, there is a hammer button is there. So you can press that hammer button. So you can see that it has started configuring all the things. Now you see the command prompt that if there is any error is there, it will be shown. Otherwise, it will show that there is no error or no error is there. So yes, so you can see that build is finished. So zero error and zero warnings are there. So now let us move to the debug configuration. So the moment you go to debug configuration, first what you have to do is basically to select an STM32C C++ application over here. And then you can press this new launch configuration. So you are doing a new configuration over there while debugging. So the moment you do the new configuration debugging, so you can see that there is a ELF file has been generated. So that means when you see that the ELF file is generated, that means you can consider that whatever you have done till this point is good enough. If you can see that the ELF file is not generated, that means it shows that there might be some problem in the code, or you might have done some mistake when configuring that particular loop in the first time itself. Okay, so let's go to debugger. So in debugger, so there are several configurations that have been already made by this particular app itself. You don't have to think about that. So you just make sure that your interface is basically SWD, and you just select that ST link. So this ST link is basically that ST link linked on this particular node itself. So by scanning, what it will do is basically it will scan all the components and it will try to fetch that whatever ST that is basically embedded on this particular node itself. So we can scan it. So yes, you can see that this ST has now been captured over here. So after that, don't change anything over here, and you can press apply. And then what you do is basically debug. So now you have done all the debug configurations. So now you can see that has started debugging. So we'll switch to perspective. So now you can see that it shows that download verified successful. What does this mean? This means that whatever code you wrote over there, now it has been it is being dumped on this particular portal. So here, if I just show you, or let me just make a video on my screen for this particular code itself. So here you can see that
So
this
here you can
particular
see that
LED
this
is now
particular
blinking. So
LED
what does
is now
this mean is
blinking.
basically,
So what does this mean is
as
basically,
when the LED is blinking, it means
as
that now
when
the
the
code is
LED is
now
blinking, it
have
means
been
that now
dumped
the
over
code
here
is
and
now
it is
have
waiting at
been
this
dumped
particular
over
point.
here, and it is
So
waiting at
the
this particular
so in
point.
the
So
screen
in the
you can
screen
see
you can see,
that
there is
there
there
is
is
something called HAL in
at
it.
HAL in it,
Now at HAL in
the
it,
code is now halted
the
over here. So that is why this particular
at HAL in it,
LED is
the
blinking. So
code is now
code is now
halted over
halted over
here.
here.
So that is
So
why
that is
this
why this
particular
particular, so what will
LED is
happen is that
blinking.
the code
So
will
the
jump
moment
from
you
here to
run
here,
your
your
code
code, and
fully,
then
what will
what will
happen is
happen
that
is that
the
the
code will
code will
jump from
jump from
here to
here to
here,
here,
and then
and then
whatever
whatever
operations that you
operations
have
that you have
configured through
configured
your
through
C
your
code,
C code,
that will be
that now you can see
executed.
that this LD2, if I just zoom it a bit more, this LD2 is now
So let me
blinking.
just run this. So over here you can see that this green button is there. So this is basically resume option. So you can just resume this one. And if I just resume it, and if I just simultaneously start recording the video again of this particular board itself. So just zoom it a bit. So now you can see that this LD2, if I just zoom it a bit more, this LD2 is now blue. So in this way, we can do the LED blinking operation over here. So over here, we have seen that this LED blinking operation code, or whatever we have written uh, over here, we have done two operations. So it is GPIO pin set and GPIO pin reset. So you are setting the pin, you are giving some delay, then again resetting, and then again giving some delay. So you can avoid this part as well. And what you can do is basically you can put another command. So that is called GPIO HAL GPIO toggle. So if I just remove these things, let me just remove this particular part. This might not be useful now. So HAL GPIO. And what you have to write is basically it will be toggle pin and then LD2 pin GPIO port and LD2 pin. So then you don't have to pass this set and reset command manually. So it will be setting and resetting the LED by itself and based on this particular delay that you have written over here. And then what you can do, you can again just then first you need to stop this thing. So we have now stopped this port. So you can see that shutting down and exit. Okay, well and fine. Now let us compile this new thing. So again, it will take some time to compile the whole thing. So again, you can see that it has been built finished with zero error and zero warnings. And now to do the debug operation again. So the moment you do the debug operation, you can see that it has now been downloaded and verified successfully. So if I just show it again, if So again, you can see that the code is now halting over at this particular place, and simultaneously you can see that HAL init over here, the code is halting. So therefore, there's a breakpoint is here. Now we just can resume it until this point. You can see that LD2 is not blinking. As soon as I press this particular resume button, you can see that LD2 has now started blinking. So again, we can stop this particular code from executing. So again, you can see that it is shutting down. So in this way, we can actually do our first operation with this particular Nucleo f401RE board. That is, it is being used. The LD2 pin has been used over here as a GPIO output. So we have done the LED blinking operation with this particular pin.